All right, so I'm going to talk to you guys about a project I've been working on with Dr. Ravi Kumar for some CS 495 credits, a special project, and it has to do with the design of approximately correct finite automata for non-regular languages. I'm going to spend a little bit of time with theory of computation review, because for some reason that's one of the courses, I don't know, at least in my cohort, put off to the last minute. So some of you in here may not have taken it. So we'll talk a little bit about the terms I'll be using. I'll give a hopefully nice, concise statement of the problem, an outline of a solution, and we'll talk about next steps. So theory of computation review. So an alphabet, you don't have to like memorize these, but I just want to say them because I might use them and you should know what they mean. An alphabet is a set of symbols. This can be like the alphabet we're familiar with, 26-letter alphabet of lowercase a to z, right? This is the binary alphabet, 0 and 1. Or it can be more complicated, right? These are all tuples of zeros and ones, right? Or two tuples, I guess, pairs. A string is a sequence of these symbols. So here we have my advisor's name, which is a sequence of symbols from the, I guess, 52-letter alphabet of upper and lowercase characters, right? A bit string over the binary alphabet, and then just a string of 3 symbols from this more complicated alphabet. Nope, too much. Okay, so a language is a set of these strings, and we say over an alphabet. Some examples are all bit strings ending in 0, 1, 1, right? That's an infinite set because you can prefix it with strings of any length. As long as it ends in 0, 1, 1, it's in this language. Another is strings over the alphabet containing A and B, so just strings containing A's and B's, containing an odd number of A symbols, right? Also an infinite set. And then this much more complicated example is strings of the form, here we have triples, where each element of the triple comes from the binary alphabet. And then I say the numbers A, B, and C represented by each row, which is to say kind of A, this is the first digit of A, second digit, all the way to the last digit, right? So this is a number, this is a number, and this is a number. These numbers satisfy the condition that A plus B equals C, right? So you can kind of picture that. And that's one language. Sequences of tuples like this that don't satisfy this condition are not in the language. Sequences of tuples that do are, right? So to start talking about deterministic finite automata, which is, it gets at the heart of the project, I want to introduce the concept of a regular language, which is a language like this for which some DFA recognizes it. So let's talk about DFA. So I've included in an example DFA that recognizes bit strings, strings of the binary alphabet, that end in 0, 1, 1. It's just a state diagram, right? So 4 states. These are transitions. When you're reading an input string, you process it one symbol at a time. You start here, that's what this arrow means. And then if you see a 1, you end up in this state. If you see a 0, you end up in this state, right? So one of the conditions for a DFA is that it has to have outgoing transitions defined for all inputs. So you'll notice that all 4 of the states have transitions on both 0 and 1. It's very well defined. This here is marked with a double circle. And if you end in this state, having read all the input, that means the DFA accepts or recognizes, I guess you could say, the string that you're processing. So the set of strings recognized by this DFA is all strings ending in 0, 1, 1. And you can see that the only way to get to this state and stop in this state is to have your string end in 0, 1, 1, right? Cool. So I already mentioned that outgoing transitions have to be defined for each state. And we talked about accepting, right? So the set of all strings accepted by a DFA is the set of strings that's recognized. It represents the language that's recognized by the DFA. That's kind of the terminology here. Okay, so here is and I wanted to make a point about these example languages I gave you on the previous slide here. All of them are regular, which is to say a DFA, like the one you just saw, recognizes each one of these, or exists there exists a DFA that recognizes each one of these, right? We saw this one. And you can imagine some techniques to track whether the number of A symbols in a string is odd, right? It's actually kind of surprising that this sort of addition language here, if you will, is regular, but that happens to be regular too. You can imagine sort of in your concept of state keeping track of a carry as you loop over the input. Cool. One language that is not regular is this one. So the strings, the alphabet is the same, right? We have triples from over the binary alphabet, I guess you could say, sequences of these things, with each row representing a number. But here they need to satisfy the condition that A times B equals C, right? Instead of A plus B equals C. And it turns out that this language is not regular. And I won't subject you to a proof of that. But that means that there is no finite automaton that recognizes this language, which is kind of sad. So kind of the motivation for this research question is that finite automata are a really simple computational model, and it'd be nice to be able to solve problems with them. But multiplication is one that we can't. So the question is, can we use discrete finite automata to solve multiplication problems approximately, right? So for this project, we're considering a simpler language, L. So we've got just two numbers, A and B, input to the DFA as these sequences of tuples. And we want to know if the product of these numbers is 2n bits. Here's a note from 242, I guess, if you remember it, that if A and B have n and m digits, their product is n times n digits or n times m minus 1 digits, right? So some of the strings, some of these sequences of tuples are going to yield 2n-bit products, and others are going to yield products with a smaller number of bits, right? Now, this language is not regular either, so we're going to talk about a procedure for identifying most cases where the product is 2n bits. So this is an outline of the approach. We're going to fix a number of states n, right? If you had an infinite number of states, it wouldn't be a finite automaton anymore, but you also wouldn't be able to solve this problem. Or no, you would be able to solve this problem with an infinite number of states, but it wouldn't be a finite automaton. So we're going to fix a number of states n, say 50. We're going to need some notion of probability here. We're going to be interested in particular in the probability that a given string is in the language given the input so far, right? And then using these probabilities, we can design, well, so I'll present to you a simple algorithm to allocate states of the n states we're given to sort of approximately solve subproblems. So I think we'll jump right into the procedure. So build DFA is, I call it a procedure because it's not written out quite as neatly as an algorithm should be, but hopefully I can get the gist across. So it takes as input this incomplete DFA. It starts with a start state, an accept state, and a reject state. And the accept and reject states, once you transition to them, I say absorbing. That just means that you can't get out, right? So cool. So we'll start with that. The procedure also needs a state in M that has no outgoing transitions that we kind of want to, this is sort of the root of our subproblem. We need n, right, the fixed number of states that we're allowed to allocate to state Q, if you will. And then the input read so far is important for calculating these probabilities. Cool, and it outputs the completed DFA, and if there are any leftover states, I mean, so better algorithms might not leave any states left over, but maybe we can solve the problem pretty well and still have leftover states, so it's possible that we want to keep track of that. All right, and I'm going to walk you through this, I think. So this first step, we're kind of going to hand wave the actual calculation of the probabilities, but let's assume that we can actually tell, given an input so far S and an input symbol I that we just got, can we calculate the probability that this string is going to be in the language, right? So let's say we have a way to do that, first of all. And in a couple slides, I'll present our way of doing that. We define this sort of naive uncertainty function. The closer that probability is to 0.5, the more states we want to allocate to the problem to try and identify which it is. And then this is framed recursively, right? So if this is going to be the number of states we allocate to each input symbol, if we don't have any states, except if our probability is closer to 1 and reject if it's closer to 0, we'll just take the hit if the probabilities aren't equal to 1 or 0, and that's where the approximate part comes in. Otherwise, allocate more states. So the part, I'm running out of time, so the part I really want to talk about is the method for calculating these probabilities, because it's pretty ingenious. And so Dr. Ravi Kumar definitely helped me a great deal with it. I can't take credit for it completely. So the problem is, given input so far, there's an infinite number of possibilities that can follow it, right? So how do you calculate a probability over an infinite space? If you sort of shift the decimal point, right? Instead of treating x1, this number, as the integer represented by all of these bits, treat it as the fraction represented by 0 point all of these bits. If you do that, then you actually can come up with some bounds. The largest possible fraction like this, of this form, is going to be greater than this number, because a bunch of zeros is the smallest number you can get, and smaller than this number, which means now we're asking the question, is their product greater than or equal to 0.1? Because that, if you multiply two numbers of this form, if the product is greater than or equal to 0.1, that's equivalent to saying that the integers represented by these strings have a 2n-bit product. And it's actually pretty rare in research that this boils down to such a simple problem. So calculating the exact probability is equivalent to finding an area. And I was just very thrilled when I figured this out, because this is just taking an integral. So if you've had Calc 2, that's very simple to do. This is an elementary function that it's really easy to integrate. We can find that area and calculate the exact probability that, given input so far, our input string will be in the language. So I've got some next steps here. To really complete this project, I definitely need to gain some insight about how accurate automata constructed by this method are, right? Because if somebody proposes a better method, there's no way to compare, So that's really the first thing. There's also, the question about how useful it is, right? Because we're not actually performing multiplication, we're just analyzing a language of strings related to multiplication. So, and various improvements to the method that I've already talked about. And that's it. Thank you for your attention.
All right, our next talk are Arthur and Zach, and the scheduler problem. They started this project in CS3.5 and then continued it on. Please.
Well, hi, everybody. My name is Arthur Woodrich. I'm Zach. And currently for this semester, we've been working on a project with Gushesh. It is a direct extension of our database class, for our project in database. So the project we worked on in databases had to do with scheduling and generating schedules depending on the time constraints of classes, and how could students actually load classes into a schedule and then into a schedule and then generate a schedule based on time frames, and exactly how you can match them up and not have any conflicts with the schedule. So the objective of our project so far has been to provide a way to visualize schedules for students that's not inside PeopleSoft and not on a written paper, not kind of in an actual schedule. And then kind of the crown jewel of the project is to actually allow students to search for classes more readily and more easily than through PeopleSoft or on a catalog. So we're actually going to show you the project that we demonstrated that we made in CS 355, I mean. So let's get that running. You want to use the D-sub?
Is that HDMI?
Yeah.
That'll work.
All right.
Let's see. All right, so this is our project from last semester. So it allows you to, first you go to a classes section. You can either search by the name of a class or the subject. So let's say I want to take CS 351. I want to take CS, I don't know, 340. And then I also want to get some of my general eds out of the way. So let's do B2. And I like the biology classes, so let's, I want to take one of these ones. So any of those three, I don't mind. I just want to see all the schedules it'll generate, and then maybe a C1 requirement. So here's some AMCS classes. So now on to the left here, I can hit this, and it will give me all the schedules that are possible with those restrictions. So you can, click through there, see all your schedules, and it also gives you the ability to add some filters to that. You can get rid of, if you see a certain class that's at a bad time that you don't want, like you can remove that class. You can remove the entire course and it'll regenerate a new one. You can say you don't want classes earlier or later than a certain time. So that's how far this application got, which is pretty close to where we want to be, but the act of actually adding classes isn't very user-friendly. It might be a little bit better than PeopleSoft because you can actually search by GE and whatnot.
It's not hard.
But but it doesn't. We wanted something more robust, something even easier than this. So that leads us to what we've been working on currently.
All right, so that's kind of the proof of concept of what we were working on in CS 355 database. So we wanted to take this one step further. We actually wanted to replace how you search for classes in general education categories, and we wanted to make it more intuitive and easier for a student to actually find exactly what they're looking for. So our solution was to take single strings and try to map those into relatable classes or queries that you would actually ask the database. So the sort of questions that we're trying to solve is a student would ask our application, what GA classes fit in my schedule, and then what schedules can be possible for classes on, for my example, Monday, Tuesday, and Friday. These are the sort of questions we're hoping to answer. So I feel a comparison with the old way on how you would do it prior is good to really emphasize how powerful this tool could be. The old way, you would have to search on PeopleSoft, type in the course that you're looking for, potentially add it to your schedule, and maybe get a conflict resolution or get a conflict or something like that. It wouldn't add. Either that or you could do it the really old school way of plotting it on a schedule and using the catalog, but none of us want to do that anymore. So Zach and I, we're proposing a better way to do this. Simply type what you want, and the program will respond to exactly what you're looking for. So queries such as general education, B3, biology, would map to all the GE B3 biology courses currently being offered for this semester. And data structures would return the single data structures or the 2 data structures classes that are currently being offered. And 4-unit Monday philosophy. A question like that could take a long time to answer on PeopleSoft or using a catalog. So that's really what we're trying to solve. One of the major problems we had designing an algorithm, one of the major problems we had designing this algorithm was actually attaching context to the individual search terms and using those search terms with their context to map it to what the user actually wanted. So to combat the first problem, mapping terms attributes, we kind of decided that certain terms have an implicit structure, such as time, weekdays, and general education codes, which is implicit in the actual token, the actual term. Something like time is separated by its two numbers, a colon, two numbers. The general education codes, they start with the GE, have A at the end. And to actually solve those sort of identification problems, we use regular expressions to map that to the attribute. Other attributes that don't really have a defined structure implicitly, we need to actually query the database to actually find out, hey, are you part of this attribute? So an example is Kushesh 12 p.m. The term Kushesh, it doesn't have an implicit structure. That could mean a professor, a subject. It could mean a multitude of things. So we actually have to access to the database and say, hey, does this make sense as a subject? And the database hopefully is going to say, no, that doesn't make sense as a subject. That makes sense as a professor. So then that's how we actually attribute the term Kushesh to a professor. Where 12 p.m., that's two numbers followed by two letters, where we can kind of conclude that that's a time because it's implicit within the structure. And to combat another problem is taking all the search terms with their context and actually mapping the entire sentence and the entire structure into a meaningful query or meaningful results where there's ambiguity and the potential for duplicate attributes. Where we have three examples here. Well, the main example, CS Ravi Watts, could have multiple meanings depending on who interprets it or how you interpret it. It could potentially mean all the CS classes or all the Ravi classes, the courses that have Ravi teaching as a professor, or it could have all the courses with Watts as a professor. It could alternatively mean give me all the CS classes that Ravi teaches and all the courses that Watts teaches, and the third. So we're actually going to demo now what we've been doing to combat this problem and sort of give you meaningful results from strings.
Do you have that? What was it? Yeah. Okay, so we give you a Google-esque search box that you can type right into. Move it. Oh, sorry. All right, there it is. So you type directly into it and it figures out what you mean. So for the example we just had, CS Ravi Watts, the way we interpret that is that you're searching for CS classes that are taught by Ravi and also CS classes that are taught by Watts. There's no really correct way to interpret it necessarily, just the most intuitive. That's what we felt. We're going to be interested in what other people think about these sorts of problems. But we wanted to make it so all the different possible meanings we had are accessible to someone trying to search. So we have a comma operator that will basically split the query. It'll interpret this as an individual query, and it will keep going from here. So the second example had a CS class taught by Ravi and any classes that Watts teaches. And then you could also add another comma there. You can get all the CS classes, which is kind of not so meaningful of a search, but all the CS classes, all the classes by Ravi and all the classes by Watts. And so right now it's able to search based off of GE codes, so you can do GE like B3. If you want to see the biology ones, you do that, it updates. If you want to see ones that are on Monday, in addition. And it shows you all basically how it's parsing it and giving you the results. Right now we're only displaying the title, but it'll be more useful once we have all the data. We just need to get a little further in displaying it nicely. So with this information, we have the actual, sections and the ad code and all that information. Yeah, you can.
Yeah, it's just looking how easily you search through this and then compare it to the old way. This we're hoping will kind of revolutionize how you search for classes at SSU.
And the end goal being, by doing this search, you can generate a schedule similar to that first application that we showed, and then easily see what all your options are.
All right, our timeline is to hopefully get this completed and ready for students to use in fall 2015. And if you have any questions or comments, does anyone have any questions?
Are you guys manually putting in all these classes and professors and vehicles and stuff like that, or are you parsing it somehow?
The Sonoma State website has an Excel sheet of all the classes and with the kind of the information about all of them, the professor, the ad codes and all that information on their website. And Professor Kushesh is also able to generate a similar report that will allow us to kind of determine how many people have been added to a class and if there's actually availability in a class or if it's a wait list or what the situation is there.
There's a question back there.
Oh, can you do things like you would in Google, like say minus keyword and it doesn't bring up the keyword?
Okay, yeah, the only operator we have right now is the comma to separate the different search queries. That's definitely an option we've been pursuing.
Certainly possible, and within
Yes.
the framework we've built, yeah, we can. It's just a matter of adding the different functionality to it at this point. Thank you.
I just have one quick question. So are you guys looking to publish it independently or trying to get the school to host it?
The school hosted. This is all a project through Sonoma State. We're not looking to go independent with it.
I know there are a lot of questions about this, and this is of interest, of course, to many people. We're hoping that, like Arthur said, that this becomes available to especially CS students for fall, just for testing. Thank you very much. Do you have any questions and comments? So our next event is appreciated and recognizing those who have served our department and the capacity of being officers for the CS Club or WICS. And here's Dr. Moore.
Sure, yeah. So let me start with the CS Club. So first of all, Nick Mankey has been our CS Club president this year. And Christy Yost has been our club vice president. Don't get too far, you guys will do a group picture with your actual club officer. Jolie Nazar has been the secretary. Yeah. For Jolie to go. Maggie Hyde has been the treasurer. And Nick Morrill has been public relations, or whatever term you guys are using for that. Do you want to do the picture with your actual club?
Oh, how about that? Right over here. Thank you.
You need to not go too far. Okay, so I guess as the WICS advisor, let me do the WICS ones now. So you may recognize a few of these people from 10 seconds ago. So Christy has been the club president of WICS. And Jolie is the vice president. Melissa Morrell is the treasurer. Lauren Loudermill is the secretary. And Maddie Hyde has been the event coordinator.
sorority roll?
Story's well.
I think you're the only one who can do that.
And I ask for the CS faculty to please step up here. So while that's happening, Dr. Stauffer, I'm sorry to say that, not to say it, but you're still the faculty in computer science department. Of course, you all know Dean Stauffer, the Dean of the School of Science and Technology, and of course, the faculty in the computer science department. I see Mike live over here. Please, Mike. So the next event is to recognize students who are graduating with distinction. These are students who have GPAs of 3.0 or above, and that they have demonstrated the depth of their understanding in more than one course through projects that they have carried out, and also have contributed to the department's social events. Specifically, for example, the club events and other events that are important to our department. For example, Dr. Reboir every semester goes to CS 101 and gives presentations to CS 101 students with the hope of bringing students to the CS department. And those are activities that we need students for, and we need our students to really show what this department means to them and to invite new members to the department. So we recognize the students who are graduating this semester. This year we had two distinctions last semester, Tim Dovey and Matt Hardwick. These are graduates for this semester. Let's start with Jacob Combs. Malfunction is part of the life of computers. If you would please ultimately come back here. I understand that. Sorry. I understand that Tandra is not feeling well today and is not going to be here. Tandra Felly is the next person graduating with distinction. Lauren Latherman. Congratulations. Sure. Thank you, Lauren. Julie Nazora. For the third time.
I know, yeah, a little bit. I feel slightly less important. It's okay. I did shake a lot of hands though, so I didn't have to shake a lot of hands. So.
David Tran. Ortal Yata. SSU app person. Ortal is working on an SSU app with, he's really continuing the leadership that
There's a lot of us.
came to us through Andrew Huss. And Eric Morday is also another member of this team right now. Christy Yost.
That's what a brand dependent, huh?
Finally, I want to recognize one of our students who's really put a lot of effort into our program, into our department, through a number of different capacities she's played different roles in the CS Club, in WICS, and also has provided really leadership in pulling people together for different reasons, one of which is, for example, coming to campus on Sundays to have group study. We truly appreciate Madeline Height's contribution to our department. Her award is Exceptional Service.
Ooh.
We truly appreciate her. Madeline.
That's special.
Can we all fit into one picture?
Do I need to lay across the front?
I think so. Do it. Your model.
You're so right. I'm flattered personally.
I get that.
One more time.
I know that some of you here are wanting to hear about courses that have long wait lists, but before we go to that, I want to quickly recognize the contribution of the faculty to this department. We truly appreciate all their hard work. Thank you so much. I also want to thank Roger Mamer, who does just about everything. Of course, Liz Meyer, who makes the department actually look good. We appreciate her contribution. And once again, Dr. Lynn Stopper, who did get us, not tried to, she did get us a position, a faculty position. The search that we ran this time around, unfortunately, didn't pan out simply because we, not to anyone's fault, but we don't simply pay enough to attract faculty. And that is unfortunately universal. It's really not only us, but the fact is that we do have a position and we will try to hire the faculty next year, hopefully by changing some of the parameters. I really want to thank Dr. Stopper for that. All right, so now back to this wait lists. As you know, we have a growing department, and really it's starting 2-3 semesters back, recognizing the trend, we've tried to respond to it. So today, for example, we have 2 sections of 215, 2 sections, when I say 2 sections, it's 1 lecture, 2 labs. 2 sections of 252, 2 sections of 315, last 2 semesters, 2 sections of 242. And we also have made CS 351 and CS 415 to be every semester courses. This semester, for fall 2014, we have wait lists for CS 355, for CS 370, CS 450, 454, and 460. I'm sure you all are aware of that. We're trying to resolve the situation. The CS 355 and 370, their caps currently are set at 22. We're going to raise them to 28. So 6 seats each. And CS 355, 370 will do that today. So that's going to happen today. 355 is going to happen either today or tomorrow. Basically, 355, even those students who take that course they have some, usually they have more courses to take before graduation. I just want to make sure that we don't miss anyone there. CS 460, 450, 454, those are kind of part of the courses to deal with. Their wait lists are longer. So what we will try to do, and they too have their caps set at 22. And the intention is to raise them to 28, 6 seats per course. So what we will do is to go through the list of those who are on the wait list And those who are graduating in the fall are going to, we will try to get the top 6 into the course. Top as in using the wait list as a measure. Those students are going to get into the course, and if seats remained after having gone through all the names on the wait list and selected those who are graduating in the fall, then we open it up to the wait list. In addition to that, we are planning on offering all these 3 courses in spring 2015. So up to this point, these 3 courses, really all of these 3 specifically have been fall courses, and we're going to make them also and offer them every semester. That should therefore take care of students who are now on the wait list and are going to get into the course. A few remarks though, especially for students who are at the bottom of the wait list for these 3 courses. We are offering 415 next semester. 415 in the fall. 415 historically in the past perhaps 5 to 7 years, it's perhaps 5 years. It's been a spring course. Now we're offering it in the fall. And currently the enrollment in it is 18, and it can go up to 28. So those of you who are on 460, 454, and 450 wait lists at the bottom, please consider taking that course and enrolling in that course. The same goes with CS 351. 351 is also now every semester course. This is really this semester, it's the off semester that's being offered. Next semester is its rightful semester. And surprisingly, we have plenty of seats available in that course. And we can guess why that is. Whatever the reason, what you don't want to have is that in spring 2015, all of a sudden we have a gigantic wait list for that course. And now come fall, you have plenty of vacant seats in that course. So all I'm really saying is, please consider CS 415 and also 351 for next semester. If you're on the wait lists for the 3 courses that I mentioned, please do that. If you are not on the wait list and are thinking of taking these 2 courses in spring 2015, do consider taking them next semester, if it is possible. Questions? I know this is not easy. I do know that. But we really are trying. Dr. Stauffer.
On commencement Saturday, May 10th, do your graduates still gather for a picture?
We are hoping to gather afterwards for a picture and for a reception.
Okay. So where do you gather?
We at the Derby.
Okay.
We've sent email messages to us.
Right.
Like Dr. Stauffer mentioned, the 10th, 9 a.m. is the commencement for School of Science and Technology. And if you're graduating, congratulations to you. We have about 25 people who are graduating this year. And if you're not graduating, work hard. There has to be an answer to this. Any questions?
I have one question.
Yes, sir.
So if we're position 1 to 6 on the wait list for the backed up classes, so you guys are actually going to go through the wait list and add the people who have the most need?
That's right.
Okay.
So what that means is for 450, 454, and 460, even if you're in the top 6 spots, it doesn't necessarily mean that you will get into the course. The preference goes to those who graduate next semester. Even though this may seem unfair to you, just think about the fact that you may be in this very position the following semester. Okay. Are there questions? Yes, sir.
But when are we going to go through the wait list? When was all this going to happen?
I'm really hoping by Wednesday next week we finish the whole process. Okay. I'm still also a little intentionally I'm trying to push things a bit back simply because Ideally, what we want is to make these decisions after the grades have been posted this semester. So I'm kind of, I know that you need the information as soon as possible. At the same time, that when we have the feedback from this semester, we'd be in a better position to make that decision. Okay? Yes, sir.
When you do go through the wait lists, does it automatically, if we're on the wait list, does it automatically pop off of our schedule?
How it's going to happen is that if you're graduating next semester, we will call you and give you a permission number so that you can get into the course and remove yourself from the wait list. So the wait lists are going to get adjusted upward, as in if you're in position N, your position is going to become N less than N potential, depending on where you are. Okay? Yes.
Do you know how many students are planning on graduating for?
The bulk of what I said is really fall, right? Oh, next fall.
Yeah.
Sorry.
Yeah.
I truly cannot tell you the numbers right now. My guess is between 10 and 15, but I couldn't possibly tell you the exact numbers. And that doesn't necessarily mean, well, it is the case that for many years now, I have given multi-year schedules to students, and a good number of them take these 3 courses in fall. And that's been always the case. Now, whether they graduate in fall or not, that's a different story. Questions? Yes.
For 355 and 370, there won't be permission numbers though, it'll just go
No,
directly to the wait list.
right. Unless, again, 355, I'm hesitant to say immediately, but 370, definitely the top 6 people will get in the course if there are no scheduling conflicts, right? And also the cap, as you know, is 16 units. If that cap doesn't interfere or the number of units that you have already is not more than 12, then it should work out just fine. I just want to make sure before I finish, see if there are any comments from the faculty in the audience.
I guess, yeah, just in terms of the wait list, like, be sure you've selected the swap option because it will not move you into a course if that would put you over 16 units. And I see this all the time in 115. Like, so just be sure you're not going to get skipped once the wait list runs, whenever that is.
And do learn about the swap feature, and unfortunately, the swap feature, just like many other features in PeopleSoft, is kind of a questionable feature. Anyway, thank you so much. I appreciate it.